In this video, I will show you how to do a dilation when the center of dilation is not the origin, 0, 0. Once I show you how to do that, then I will go on to demonstrate some other really cool stuff about reflections and dilations and just answer some thought questions. It's going to be a lot of fun. For number 7, we're just going to do the same thing again. Let's dilate by a scale factor of 3 using a center of dilation of 5, 4. So let's plot the center of dilation. So this is 5, 4 is right here. Alright, so that is my center of dilation. Okay, so now let's do this one point at a time. So let's call this point A. To get from the center to point A, you simply have to go left 3. Okay, you're just going left 3. But the scale factor is 3. So if I take this left 3 and I multiply it by 3, because of the scale factor, that's going to become left 9. So that's what I need to do to get the new point. So I'm really going to go left 9. So here I go. There's 3, and then 6, and then 9. So here I am left 9, and this will be the point A prime. Okay, let's do that again. Let's call this point B. To get to point B, I would have to go left from the center. I would have to go left 3 and down 2. Alright, this is point B. So I'd have to go left 3 and down 2. Okay, but because the scale factor is 3, every motion I do needs to be 3 times as big. So this is going to turn into left 9 and down 6. Alright, I'm just multiplying every motion by the scale factor. So if I go left 9 and down 6 from the center, so left 9, that's the same thing I did before point A, but now I'm also going to go down 6. Alright, so here's 4, 5, 6. So this is going to be point B prime. Alright, I went left 9, down 6 from the center. Okay, one more time. Let's call this point C. If I want to get to point C from the center, I would have to go left 1, down 2. Okay, left 1, down 2. But the scale factor is 3, so I need to multiply all of my motions by 3. So that means the image should be left 3 and down 6. Alright, I go left 3, down 6 from the center. So that's what I'm going to do. So starting from the center, if I go left 3, I'm here, and then down 3, 4, 5, 6. That's going to be right here. Okay, so this would be point C. Well, C prime, the image. So this is what the dilation would look like. Notice that the triangle is 3 times as big as the original triangle. If you looked at the lengths of the sides of the triangle, see how the side and the bottom are each 2? And over here, the side and the bottom have length 6. So all of the lengths are 3 times as big. Okay. Number 8 is the same thing. In fact, if you've been watching the last couple of videos because you didn't understand what to do, by now you should know what to do. So you should pause the video and try to do this problem by yourself, and then hit play and see how you did. Anyway, I'm going to assume that you did that. So the center of dilation is the point -6, -6. Alright, so that's this point right here is my center. Let me see if I can squeeze this in here. Center. And we're supposed to do a scale factor of 2. So look, first of all, we have a special case here. You see this one corner of the triangle, one vertex, is at the center. So that point, if you're at the center of dilation, it's not going to move. Alright, there is no distance that we can multiply by 2. It's on the point. So this is the point, well, let's call it A. And it is also the point A prime. Alright, the image doesn't move, it stays right there. So there's that. So let's move on to what I'm going to call point B. Alright, if you want to get from the center to point B, you would have to move up 3. Okay, you have to move up 3 from the center. Now the scale factor is 2. So that means you're going to multiply this by 2. Alright, so that means you're going to go up 6. So from the center, if I go up 6, that's going to put me right here. So that's going to be the image B prime. You know what? I should have done A prime in green. Anyway, here I will put a little green right there. Now let's go ahead and do point C. If you wanted to get to point C from the center, you would have to go up 3 and right 3. Okay, you would have to go up 3 and right 3. But we are doing a dilation, scale factor 2. So I need to multiply all this by 2, which means that in reality I'm going to go up 6 and right 6. And that will be my image. So from the center, if I go up 6 and then right 6, that's going to put me right here. So this will be the image C prime. And now I'm just going to connect the dots. So this is what the image would look like after the dilation. Okay, for number 9 we have a quick fill in the blank. Hopefully you can see the original image that's here. That's just an outline. Well, they said the dark shape was reflected, so I guess we're supposed to see the dark shape as the original and then the outline as the reflection. But the point is, where is the line of reflection? Where's the axis of symmetry? And I'm hoping you can see that right here, this horizontal line splits that image right down the middle. Okay? If you just look at the picture as a whole, look at the original and the reflection, just look at the whole picture, and hopefully you can see that it's the same above and below this line. So this is the reflection line. A horizontal line is always going to be y equals something. So y equals what? Well, this line is at a height of 2 units above the x-axis. So this is the line y equals 2. So that's the line that the shape was reflected across, y equals 2. Alright, for number 10, where is the reflection line? And again, just look at the double image as a whole. Alright, this, to me, if I squint, it sort of looks like a paper airplane. So where's the line that splits this paper airplane right down the middle? and I'm hoping you can see that it's right here. Okay, this is the line that splits that double image right down the middle. Okay, now a diagonal line at a 45-degree angle, there are two of those with which we are familiar. We have the line y equals x is one of them. Alright, the line y equals x is a 45-degree, a line that goes diagonally 45 degrees, that goes up from left to right. It's going upward. Now, this green line is going down from left to right. So this is the line y equals negative x. Okay, now here we have a couple true-false questions where we have to explain what we're doing. But here's the background information. Imagine that you are going to do a dilation of triangle ABC with a scale factor of 2, using the point 4, 4 as the center of dilation. Okay, now we need to answer these questions. So first of all, and you don't have to do the dilation to answer the question. You can use your imagination if you want. For instructional purposes, I am going to actually do the dilation. But feel free to try to answer these questions before I do the picture. So point A prime will have the same coordinates as point A. Just at a glance, I believe this is going to turn out to be false. And here's why. The center of dilation is at 4, 4. Let's plot that. So if I go over 4 and up 4, okay, right here, point C actually is the center of dilation. Now, the only way that the original point and the image are going to have the same coordinates, the only way a point is not going to move when you do the dilation is if the point is at the center. So look, point C is going to have the same coordinates as C prime, because it is on the center of dilation. Point A and B are not on the center, so they are going to move. So this is definitely going to be false, and you know, there are different things that you can write, but I'm just going to say that point A is not at the center of dilation. You know what? I think I can type on here. Let me try that. Will you let me type? Point A is not at the center of dilation. So it will not have the same coordinates. After the dilation. Alright, in other words, it will move. Okay, that's another way of saying it. Okay. Can I make this a different color? Boom. Okay. I am going to do this dilation, but let me see if I can answer the other question as easily. What about point B prime? B prime will have the same coordinates as B. Explain your answer. Well, that's the same thing. Point B is not at the center either. So it's going to be the same answer. So this is also going to be false. And my explanation is identical. So I'm going to see if I can cut and paste this. Control C, Control V. Boom. Let's see. Why are they covering it? Okay, true or false? Point C prime will have the same coordinates as point C. Explain your answer. Well, now we're talking. This one's going to be true. point C is at the center of dilation. So it will not move when you do the dilation. Okay, so this one's going to be true. And I think I'm still going to cut and paste my previous answer. Oh, you know what? I should have said point B for the previous. Point B is not at the center of dilation. So now I'm going to say point C is at the center of dilation. So it will have the same coordinates after the dilation. It will not move. Okay, this is great. So far, so good. Alright, part D. The image's perimeter will be the same as the pre-image's perimeter. Explain your answer. Okay, hopefully you understand that the perimeter is the distance around the edge of this shape. Alright, if I added up the lengths of these three sides, that would be the perimeter. But there's a scale factor of 2. So one thing I know for sure, if I do this dilation, the image will be twice as big as the pre-image. So that means the perimeter will be twice as big. All of those distances will double. So that is definitely going to be false. Okay, I lost my pen. Alright, that is going to be false. And here I'll type something up. So I said since the scale factor of the dilation is 2, the perimeter of the image will be double the perimeter of the pre-image. Alright, how about part E? The image's area will be the same as the pre-image. Well, that is clearly false as well. The image is going to be twice the size of the pre-image. So, yeah, false. Since the scale factor of the dilation is 2, the size of the image will increase. Now, funny story, while the lengths are doubling, right, with scale factor of 2, the area does not actually double. The area will actually be 4 times the size. Okay, and if you're curious about why that would be, just real quick, imagine a square that has a length of 1. Okay, so the lengths are 1 by 1. What would be the area? I'll put that on the inside here. Well, the area is the length times width. So the area of this square is also 1, because 1 times 1 is 1. Now, if I do a dilation, okay, a scale factor of 2. So if I take this and I multiply the lengths by 2, what do I get? So now I'm going to have a bigger square, and the lengths have now doubled. So now my new square is going to be 2 by 2. But what about the area? Again, the area is the length times width. 2 times 2 is 4. So even though the lengths have doubled because of the scale factor of 2, the area actually goes from 1 to 4. Alright, the area is actually 4 times as big. Okay, look at question F. True or false? The image will be similar to the pre-image. That's definitely going to be true. You know that when you do a dilation, the size changes. It might get bigger or smaller, but the shape does not change. And look, that's right here in our little mini glossary. Similar is when you have different sizes, but you have the same shape. So that's exactly what happens when you do a dilation. So last question. True or false? Side B prime C prime will be vertical. Well, look at the original pre-image. side BC. All right, side BC is right here. And since BC is vertical, then the image of this is also going to be vertical. We're doing a dilation, guys. We're not doing a rotation, okay? This is going to get twice as big, but it's not turning. Okay, I think I went too far. 3, 4. Yeah, it should end right here. So when you do this dilation, it's going to be like this. All right, I went too far. So bootleg this drawing. But yeah, B prime, C prime is still going to be vertical. Okay, in fact, when you do a dilation, all of the sides remain parallel. So see the original pre-image of AB. The image A prime B prime is going to be parallel to the original. The sides stay parallel. So if the original line is vertical, the image is going to be vertical. If the original line is horizontal, the image is going to be horizontal. If the original line, the pre-image, is diagonal, then the image will also be diagonal. It's going to be parallel. So this is one way to say it. It's true because since segment BC is vertical, and then the image segment B prime C prime will also be vertical because the image is always parallel to the pre-image after a dilation. Alright guys, that's going to do it for this video. Go ahead and click here in the red apple to watch the next video. Click in the green apple to subscribe, or click the yellow apple for the full playlist.